P.6. I'm probably going to take the whole time because this is a lot of stuff today. Sorry, James. All right, this is, we're doing the whole lesson today, which is why it's going to take a little while. But this is all review, except for there's some trickier parts this year. Complex numbers. Okay, let's do a little introduction into what a complex number is. Because people actually call things imaginary numbers, but they're actually complex. I'll show you. So, when you took Algebra 2, a long time ago, last year, you learned all about real numbers. And if you were a real number, you had one of two ways that you could go. You could be either rational, which are the nice numbers, integers, decimals that end, decimals that repeat, fractions, or you were irrational, which were numbers like rad 2 or pi or e. Remember the letter or the number e? It's also a letter. And then if you're a rational number, then that means you could be an integer. Integers are positive and negative whole numbers. No fractions or decimals in integers. And then if you were an integer, you could be a whole number. If you remember whole numbers, those were the ones that start at 0, 1, 2, 3, 4. And then after whole numbers, those were natural numbers. And natural numbers are the counting numbers, so we get rid of 0 and start at 1. Do you remember learning all that last year? Yeah? Yeah. And then that was, first semester. And then second semester, we decided to say, okay, there's also something called complex numbers. And in the world of complex numbers, that's where the number I comes into play. All right, so let's talk about complex numbers today. So 17th century, some math nerds got together and they wanted to solve that. But as you know, there's no real number that you can square it, add it to 1, and get 0. So they decided, you know what, let's make up something. That's exactly what they did. And they said that we're going to make up a number, and we're going to say that this number is I, and it's equal to the square root of negative 1. And then people were really upset about it. No, those are imaginary. Those aren't real. Those are fake. And then that's how it kind of stuck. They were called imaginary numbers. So if I equals the square root of negative 1, then I squared equals negative 1. And it's the first time in your whole life that you squared something and got a negative. And it was like, whoa, what are these things, right? They're fake. You're right. They're imaginary. They're not real. But they are actually, they show up in real life. It's crazy. Okay, so an imaginary number is something like this. 5i, negative 3i, 10i. Okay, those are all imaginary numbers. A complex number is a little bit more complex. Now, actually, imaginary numbers are complex numbers, but complex numbers look like this. 2 plus 5i. You see the difference? It has a real part and it has an imaginary part. So people will call this an imaginary number. They're actually technically wrong. It's a complex number, but I'm not going to be picky about that. So that's the real part, and that's the imaginary part. There you go. And standard form of an imaginary or complex number, see, I do it all the time too. I say imaginary when I mean complex. Standard form of a complex number is z equals, they call them z a lot, z equals a plus bi. Standard form. So the real part first, imaginary part second. Okay, now what are we going to do with these? Oh, so much fun stuff. We're going to do some operations. We're going to add, subtract, multiply, and divide. All right, so let's do some operations. Let's get some imaginary and complex numbers, and let's go ahead and combine them, subtract them, do all the things. Here we go. Number 1. Suppose that you have 7 minus 3i plus 2 minus 6i. And we are going to do the operation stated. Now, it's funny. Every year, I'll have this in Algebra 2. and I'll have two binomials next to each other, super close, and people don't look at it, and what do you think they do? They FOIL. Yeah. It's terrible. No, this is not a FOIL problem. It's an addition problem. So we're going to take our like terms, our real parts plus our real parts, and our imaginary parts plus the imaginary parts. So 7 plus 2 is 9. Negative 3i minus 6i is negative 9i. Do you remember doing these last year? Yeah, good. All right, so that's pretty easy, pretty basic. Number 2. What about subtracting complex numbers? So 2 minus I minus 8 plus 3i. It's a little tricky. And over the years, you start to get used to the mistakes that people make. And the mistake that people make here is they forget to subtract the second half, right? So they'll go 2 minus 8 is negative 6. But then we need to go negative I minus 3i is negative 4i. Okay? So be careful with those. Subtraction is always a little trickier than addition. All right, let's move on. I'm insulting your intelligence. You're like, come on, let's do some good problems. Here they come. Number 3. You're okay with these? Yeah? You like them? How about 2 plus 3i times 5 minus I? So this is a FOIL problem. And I want you to do these by hand, even though you know that I know that I know that you know that your calculator can do these. Or maybe you don't know that, and I shouldn't have told you. But we're going to do these all by hand. So here we go. We're going to FOIL it out. So we're going to do, first, 2 times 5 is 10. Outside is 2 times negative I, so negative 2i. Inside is positive 15i. And last is negative 3i squared. All right, now we have a couple of things to fix here, okay? First of all, this right here, this negative 3i squared, you can never leave powers of I, not I cubed, I squared, I to the 4th, never. They can always be simplified. What is negative 3i squared? Do you remember? Positive 3, yeah, because this is negative 3 times negative 1, which is positive 3. Remember, I squared equals negative 1. So you always have to fix that. All right, so then we get 10 plus 3 is 13. Negative 2i plus 15 is 13i. And that's the way it would be simplified. Yeah, so 3i squared. So remember, always remember that I squared equals negative 1. So anytime you see that, you have to replace it. So this is negative 3 times I squared, which is positive 3. Yeah. Oh, and there's Benny. Did you see Benny? He's so cute. Look at, there he is. Binomial Benny. No? Lenny. Oh, we'll get to Lenny. Lenny's just a baby. All right, number 4. He's only one. He's always one. All right, how about this one? 5i cubed. 5i cubed. All right, a couple ways to look at this. First way is you just cube it all, right? You cube the 5, you cube the I, and you get 125i cubed. Now, I'm not going to leave it like that because I can never leave powers, bless you, powers of I, ever. Okay, so what you can do is you can split this up. I cubed is I squared times I. Do you agree with that? And then what's I squared? Negative 1. So this is really negative 125i. That's one way to do it. Some people, they like to do it this way where they go 5i and they write the whole thing out, but I just think that takes a little longer. So then this would be negative 25 times 5i equals negative 125i. So either way you want to look at it, it's fine. Okay? All right. Now we're going to do the problem that in first period they said I ruined their day. Here we go, number 5. No, I'm about to. All right, here we go. Suppose that we are told that z is equal to 1/2 plus rad 3 over 2i. Okay, so not only do I have fractions, I have radicals in a complex number.
Why would you do that?
Because it's awesome. And here we go. We're going to do two things. We are going to find out what z squared is, and then we're going to find out what z cubed is. Okay? Well, z squared's the hard part. Z cubed's going to be easy, because once we have z squared, then we can just do z squared times z, and z is this. So we'll do this answer times that. There you go. But the z squared, that's the tricky part. So here we go. We're going to take 1/2 plus rad 3 over 2I, and we're going to square it. There's a couple different ways to do this problem. Now, if you're like me and you get a little mixed up with all these fractions and stuff, you can actually factor out the 1/2 to the front and then FOIL the other part, which I think I'll do that. I did it that way earlier. We'll see. So if I factor out a 1/2 from both of these terms, I end up with 1 plus rad 3I, and then the whole thing is still squared. Okay? So all I did was take the 1/2 out so I don't have to deal with fractions while I'm foiling. So to FOIL this, to square this whole thing, you do need to square the 1/2, which is 1/4, and then you need to square this. Okay? Bless you. And I'm going to write it out as 1 plus rad 3I, 1 plus rad 3I, because I'm squaring it. So I squared this 1/2 to get 1/4, and I'm squaring this, which you can use your that shortcut when you square a binomial, but I think this is really complicated, so I wanted to write the whole thing out, and now we're going to FOIL. Okay? All right, so leave the 1/4 out of this mess, and we'll go ahead and FOIL this out. So I have 1 times 1 is 1. 1 times rad 3I is rad 3I. The middle term, 1 times rad 3I, is rad 3I. And then my last term, what's rad 3 times rad 3? 3. And I times I is I squared. So far, so good? You all followed that pretty good? Okay. So now let's simplify. So I still have that 1/4 out front. This 3I squared is -3. Okay, and I can always combine that with the first part. So 1 minus 3 is -2. And here's the part where the people got really upset first period. So what's 1 rad 3I plus another rad 3I? How many rad 3I's do you have? 2 rad 3I. People didn't like that. Do you like that? I know, I thought that was okay too. Maybe I didn't explain it very well earlier. We'll see. All right, I'll blame it on myself. Go ahead and distribute the 1/4. And so our answer would be -1/2 plus rad 3 over 2I. Beautiful. Right, Bobby? Love it.
Wait, that's where we started.
It's not, though. It's almost where we started, right? I know.
So can we just cut that?
No. Oh, okay, so that's letter A. That's the answer to A. That is Z, sorry, that's Z squared. I wrote Z equals, it's Z squared. Z squared equals that.
Wait, so all you did was move the square to the Z. The 1/2 is negative.
The 1/2's negative. All right. No. So now we have to do part B, which is to find Z cubed. So Z cubed is to take Z squared, which we just found, and we're going to multiply that by Z, which is 1/2 plus rad 3 over 2I. Okay. So we're going to FOIL this. Don't worry about factoring out any 1/2s or anything. Something magical is about to happen. No, it really is. Okay, here we go. So we're going to FOIL this out. So we've got -1/2 times 1/2 gives me -1/4. Good. My outside term is negative rad 3 over 4I. So it's -1 times rad 3, 2 times 2, and then there's an I there. My inside term is positive, because it's rad 3 over 2 times 1/2 is rad 3 over 4I. Ooh, that's exciting. Do you see that already? You like that? And then the last term would be rad 3 times rad 3 is 3. 2 times 2 is 4. I times I is I squared. Okay. No, I just FOILed. We multiplied fractions and radicals and all this good stuff. Now the middle ones, as you see, they will cancel out. So I'm going to go straight there and do that. 3/4 I squared, what is that? Negative 3/4. So I have a negative 1/4 minus 3/4, and my answer is -1. So good. Z cubed is -1. Did you just get goosebumps, like math goosebumps everywhere? No. I kind of like, yes! One person.
No.
Yes. And then I ruined the rest of your day. Someone liked it.
You know, yeah. Hey, yeah.
Probably on the test, too. Get that spider out of here.
You're threatening me with this, and I have to spider.
All right, last part. We've got 10 minutes. Conjugates. Conjugates. Okay, do you remember conjugates at all?
I remember the word.
Yeah? Okay, if you have Z equals, yeah, it's a Spanish word, isn't it? Z equals A plus BI, then its conjugate, which is, it looks like that. It's called Z bar. That's where I'm going to be after school today.
I don't like that Z.
At Z bar. Over at the Z bar. All right, A minus BI. I'm kidding. I'm actually going to the club tonight.
Oh,
The Sam's Club. The Sam's Club, yep. Okay. All right, so what happens is when you multiply Z and its conjugate Z bar together, something magical happens on these where you end up getting a real number. You get A squared plus B squared when you FOIL it out. Because they're opposites in the middle. You don't like Z bar?
No, I don't like anything we just did in the
You
last
should really just not take math. Okay, here we go. No, all right, number 6. All right. Now, where are we going to use conjugates? Well, in real life, never. But in this class, we will do it here. So to use conjugates, we use them when we divide. Okay, so we're going to divide 2 divided by 3 minus I. And there's a rule that says that you are not allowed to leave imaginary or complex numbers in the denominator of a fraction. So in order to get rid of it, do you remember this? Yeah. The conjugate. Yep. You multiply. Yeah. It's coming back. Some of you guys remember this. Good. You're going to multiply top and bottom by 3 plus I. 3 plus I. Yep.
This math is actually useless.
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 I use it every year. So.
That's
yeah.
you. That's you.
Yeah, just the middle sign. Just the middle sign. Okay, so we take the top and we distribute.
I'll never just like walk on the street like, oh, look at this, an imaginary number. Let me solve it. No, never mind. I made a complex number. Let me.
Yeah, haters gonna hate. All right, so.
I just remember the joke he made about Fraley and his imaginary girlfriend.
Yes, Fraley. He has a girlfriend. She is the square root of -100. She's a perfect 10, but she's imaginary. Yes, I forgot about that one. The other one is this is my favorite number. I over 8. Ooh. Okay, here we go. 6 plus.
That's actually not a number.
It is a number. It's a complex number. Actually, it's imaginary too. All right, so you get 6 plus 2i over 10, and then you want to reduce, so we're going to divide everybody by 2. So you get 3 plus I over 5. Oh, you can do a shortcut on the conjugate. So the conjugate is always 3 times 3, and then this is 1 times 1, the number. So it's a squared plus b squared. The middle ones cancel out.
So negative I squared is 1.
Yes. It's always plus because it's going to be negative I squared positive 1. You can leave your answer like this. The book might change it to this because they might separate it. I'm okay either way.
And do what the book does.
Yeah. So they just put the 5 3/5 and 1/5, and they just write it like that. Yeah. So when you multiply conjugates together, 3 minus I times 3 plus I, you'll go 3 times 3 is 9. The inside outside will always cancel out, and then you get negative I squared. Well, I squared is -1, but it's a negative 1. That middle will always be positive, always. Okay, let's do one more, number 7. Ryan's had enough. All right, here we go. 5 plus I over 2 minus 3i. Okay, same idea, same type of problem, but this one you're going to have to FOIL the numerator instead of just distributing, like the last one was just distribute the 2. So we're going to multiply numerator and denominator by the conjugate of 2 minus 3i, which would be 2 plus 3i. Perfect. Just change the middle sign, nothing else. It's 3i. Okay? And yeah, these take a while.
When they just give you, like, if they were just to give you, like, 5 plus I, and there's, like, no denominator, would you just multiply it by 5 minus I? And that's it?
For up top?
If they just give you, like, a numerator, like, no denominator.
So you wouldn't have to do that, because the reason why we're doing it is because we can't have I in the denominator.
Would you just multiply it by 5 minus I?
No.
What?
Like if they just give you 5 plus I, no. Like that's just the problem right there?
Like they tell you to find its conjugate.
Oh, yeah, if they tell you to find the conjugate, multiply it. Yeah, 5 minus I, yeah. Are those problems in there like that? Oh, okay. Okay, so let's go ahead and FOIL this out. You named it? You did not name it. Okay, 10. Outside is 15i. Hopefully you kind of started this already. And then plus 2i. And then plus 3i squared. All right, so that's the numerator. Denominator, you don't have to spend that much time on it, right? Do you know the shortcut? You take a and you square it. You take b and you square it. 4 plus 9. Okay, don't waste your time. 13, good. All right, so you have minus 3. So it's 7 plus, is that a 12 or a 2?
I don't know.
It's a 2.
It's 2.
So that's 13?
Maybe.
Did I do that right?
It's all meant plus.
15 plus. Oh, that was a plus. Okay, so that's 17.
Oh my goodness. I don't have an eraser.
All over 13. And you can leave it just like that, or you can split it up. Either way. Okay.